Hello everyone and welcome to Zelin's class again. And today we are going to talk about trigonometry integration. Well, this is a very easy topic because we have done a lot of integrations and you should also have a basic idea about what integration is going on. So it's like similar to the exponential differentiations and integrations. So if we want to figure out the trigonometry integration, we should also start from looking at the trig differentiation first. So these three are all the differentiations that we covered in the differentiation topic. And now, if so y equals sine x and y dash is equal to cosine x, and we know that differentiation is the exactly opposite with the integration. So if y equals cosine x, the integration of cosine x will become sine x plus c. And by the same time, if you want to know is it correct or not, you can just differentiate your answer to check whether is it equal to this value or not. So if you do sine x dash equals cosine x, and it is equal to this value, which means that this equation is correct. And you can do the same thing for cosine x and secant squared x. So these are the two formulas. However, maybe you will wonder that what about tangent x dx? Well, this one we are going to talk about it later because this one requires some more skills and we can't solve it straightly when you convert into sine x over cosine x dx. And we are going to talk about later when you learned some other skills in integration. Okay, so now what about these three ax plus b? Well, we have met a lot of these, like in exponential differentiations and integrations, or like the natural logarithms. So we also do the same thing as before. So I'm not going to, so you should try to find the formula yourself because just use the rule that the integration is the opposite with the differentiation, so you can find it by yourself. Okay, now there's an exercise. Well, I can write it here. So for sine ax plus b dx, this is equal to 1 over a times cosine, or negative times cosine ax plus b plus c. And this is one of them. And for this question, we can see that sine it's here is 2x plus 1, which means we need to use this formula and the 3 at the front, so let's do it. So 2 will become negative, so it will become a half, but sine becomes cosine, there's a negative here, and we times 3 times cosine 2x plus 1 plus c, and which means the answer is negative 3 over 2 times cosine 2x plus 1 plus c. Well, don't forget to write your c down if it's an indefinite integration, because otherwise you will lose 1 mark by not writing the c down. So, okay, now let's do another question, which is a definite integration. And it's secant squared 2x dx. And for secant squared ax plus b dx, we can also apply the formula so that we bring the a down, so 1 over a times tangent ax plus b plus c. So like if you do the differentiation of this, you will have a times at the front, so a and a will cancel out and you will leave as secant squared ax plus b. So like tangent ax plus b dash equals a times secant squared ax plus b, and so these two will cancel and you will get the value of this. So now let's do this one. So this one, which means we have a half at the front and times tangent 2x. And we write the brackets and we write the range. Okay, so now we use the skills we have discussed yesterday, which we sub this value in and then we minus the situation when you sub this value in. So now let's substitute 1 over 6 pi first. So it becomes a half times tangent 1 over 3 pi minus a half times tangent 0. And we know that tangent 0 is equal to 0, which means that this part is equal to 0. And for tangent 1 over 3 pi, it should be, so we need to draw the circle now, and this 1 over 3 pi is this, and we have 1, square root 3, and 2 here. So, which means that tangent a third pi is equal to opposite over adjacent, which is square root 3, times a half, which is equal to square root 3 over 2. And that is our answer for this question. Okay, so now let's do a problem solving question, which it will appear in many places. So they have given you a point, and they also give you the differentiation of the curve, and you define the equation. And we have tried several examples before, but I still need to tell you that how many steps do you need to do this. So first step, you define you need to integration. So you add this value over that, and you will have something fx plus c, because it's an indefinite integration, so we have a c here. However, we need to find the equation. So now the second step, we sub this value in to find the value of c. So now following these two steps, let's do this, which we will firstly, let's write integration of 4 sine 2x minus pi over 2 dx. And then let's solve this. So it's an equation that we should apply using this formula. And now, so we have a negative sign at the front, and we have 4 times, well, here is 2, so we become a half. And times sine will become cosine, so 2x minus pi over 2 and plus c. And this is equal to negative 2 times cosine 2x minus pi over 2 plus c. And that is the first step, so the first step we have done. And the second step, let's substitute this point in. So x is equal to pi over 2, which means negative 2 times cosine pi over 2 plus c is equal to 5. And we know that cosine pi over 2 is equal to 0, which means c is equal to 5. So our answer will be negative 2 times cosine 2x minus pi over 2 plus 5. And that is our answer. So y equals that. And that is all for today. And this is not a very difficult part if you understand the previous parts of integration. And thank you for watching this video. And if you want to do some more examples, you can go to the channel by Daniel Dallas. And make sure to subscribe this video and give a like. And I'll see you tomorrow. Thank you.